Engine ignition. And liftoff. As the countdown to Mars continues, the perseverance of humanity launching the next generation of robotic explorers to the Red Planet.
And Atlas TU has gone to closed-loop control.
We have indication that cruise stage separation has been confirmed by the spacecraft.
MRO reports the electro radio is powered on, ready to receive signals from the lander.
We have confirmation of entry interface. Perseverance is currently going 5.3 kilometers per second at an altitude of about 120.
February 18th, 2021. The descent stage carrying the rover Perseverance entered the Martian atmosphere at more than 20,000 kilometers an hour. This was the beginning of a series of critical events which had to take place without any possibility of human intervention.
We are starting the straighten up and fly right maneuver in preparation for parachute deploy.
MRO's reporting good to
For the engineers at NASA and the French National Center for Space Studies, CNES, this was the start of the 7 minutes of terror. Perseverance needed to make a soft landing on the Red Planet, the cemetery of 1 out of 3 Martian probes.
The navigation has confirmed that the parachute has deployed and we are seeing significant deceleration in the velocity. Our current velocity is 430 meters per second at an altitude of about 12
On board
kilometers.
Perseverance, a dozen highly sophisticated instruments were destined for one of the most ambitious space missions ever. To find out if there had ever been life on Mars.
Perseverance is now slowed to subsonic speeds and the heat shield has been separated. This allows both the radar and the cameras to get their first look at the surface.
The rover was now less than 2 kilometers above the Martian surface. So began the final landing phase, perhaps the most risky.
We have confirmation that the back shell has separated.
At this moment, the fate of Perseverance was already sealed. Information arrives on Earth with a delay of 11 minutes. Either the rover had landed safely, or it had crashed.
About 20 meters off the surface. UHF is good. Touchdown confirmed. Perseverance safely on the surface of Mars, ready to begin seeking the signs of past life.
That 7 minutes, I think, was the shortest and the longest 7 minutes of my life. For me, the really special moment is the few minutes after landing when we got the first picture of Mars.
All stations, stand by for the images.
Wow, my robot that was here 7 months ago, that's been in space this whole time, is on another planet.
Congratulations to the mission. And
Although this was not the first photo sent from the Martian surface, it confirmed that the rover Perseverance was apparently intact and perfectly operational. Consequently, Mars would be able to reveal some of its secrets. At more than 200 million kilometers from Earth, the rover Perseverance could try to answer a simple and head-spinning question. Has there ever been life on Mars? Over the course of a year, it leads us on a unique journey. Mars, the sister planet of the Earth, has fascinated astronomers since the dawn of time. But it was at the end of the 19th century that the idea of intelligent Martian life took shape, with the so-called canals seen by Giovanni Schiaparelli. Convinced, the American astronomer Percival Lowell mapped out these canals and wrongly concluded that they made up an organized network intended to supply entire cities with water. The myth of Martians was born, and it fed the dreams of numerous Earth dwellers. But in the 1960s, as soon as technology made it possible, several probes were sent to spy on the surface of Mars, in vain.
It was Viking in 1976 which sought life on Mars with 3 experiments, and it was looking for living life. The conclusion was that there was no life on the surface of Mars, so people lost interest in Mars for 20 years.
Since then, several rovers have roamed the Martian soil. The probe Pathfinder and the small robot Sojourner opened the way in 1996, slightly preceding the twin rovers Spirit and Opportunity. They discovered that water had once flowed on the surface of Mars. And 10 years ago, saw the landing of Curiosity, the elder sister of Perseverance. Still operational, its initial mission consisted of understanding if the presence of this liquid water, which today has disappeared, might at some time have allowed the red planet to bear a form of life.
Curiosity went to Mars to establish its habitability. Was Mars habitable 3.5 billion years ago? We found that yes, it could have been habitable. It had the right ingredients. So then Perseverance takes it one step up, right? And it says, okay, well, if it was habitable, was there life on Mars?
Like with Curiosity, various sized prototypes of Perseverance were built by NASA at the Jet Propulsion Laboratory. They were intended to anticipate every situation, thus allowing the rover to successfully carry out its mission.
Perseverance was built based on the idea of Curiosity. We took a lot of the systems that existed on Curiosity and used that as our baseline for Perseverance.
On the outside, the 2 rovers are identical. But with Perseverance, everything was rethought and improved. Perseverance's passengers are technological gems. High-resolution cameras, spectrometers, lasers, and a ground-penetrating radar work alongside an oxygen extractor, a drill, and a sample collector.
So these are extremely complex vehicles. Each robot represents the work of 150, 200, 300 scientists.
It took 6 years to develop, build it, and launch it, and then another 7 months to land on Mars. It takes an incredible amount of time to design everything, build it, make it space-rated, test it, because we also have to test and demonstrate that it's going to work in that Martian environment.
The Martian environment is hostile, but the extreme temperatures pose the biggest problem, added to which Perseverance needs to produce its own energy.
The problem with using solar panels on Mars is that you're so much further away from the sun that you need a much bigger area to get the same energy as you would here on Earth. We sometimes have dust storms on Mars, and so that's often how rovers meet their demise on Mars. For Perseverance, we use a nuclear source which over time creates heat, and that heat is transformed into electricity.
This generator will allow the rover and its instruments to function for several years without breaking down on the surface of Mars.
When when we build missions like Perseverance, it's not just an American mission. So when we build this rover, yes, it's built here at the Jet Propulsion Lab, but pieces are built all over the United States, all over the world. And so the SuperCam instrument, for example, is a French instrument.
SuperCam is the piercing eye of Perseverance. This high-technology scientific instrument, amongst other things, is equipped with a powerful laser, which, with each shot, pulverizes rock to analyze its composition. This makes it possible to identify chemical particles present in the plasma obtained by the shots within a 10-meter radius of the rover.
I can claim paternity, or at least joint paternity, with the American Roger Wiens at the Los Alamos National Lab in New Mexico. One day, armed with a scrap of paper, we said that it would be good to measure the chemical composition of Martian rocks and soil. And I said to him, "What can you do?" And he said, "We at the lab know how to make spectrometers to analyze light." Then he said, "What about you? In France, we're good at lasers." So we swapped ideas, and 20 years later, we came up with this instrument, SuperCam.
SuperCam contains a laser system here and spectrometers which make it possible, with this telescope here, to obtain extremely detailed images of the surface of Mars. You can see the details of the order of around 20 microns per pixel when the camera is closest to the ground. Here you see the first image taken by SuperCam. All the instruments can carry out precise analysis to try and determine the chemical and mineralogical composition, and perhaps even the presence of organic material.
The Americans describe SuperCam as a Swiss Army knife, in the sense that it's a tool for doing everything. Its strength as an instrument is that at a distance, it's able to spot something and say, "That looks interesting." I'll fire a laser, a red laser for chemical composition, a green laser to vibrate the molecules to show me the molecular links and structures. I look at reflections from the sun, the infrared, and I can see the molecular signature.
SuperCam is also equipped with a microphone to record sounds. You can listen to the wind on Mars. It also hears elements of the rover, when the wheels go over stones, for example, or when the laser is analyzing rocks. You hear the tick-tick-tick produced by laser fire, which indicates physical properties of the rock. Is it hard? Is it soft?
Lanzarote in the Canaries. It took 20 million years of volcanism to give this island its unique aspect. Its characteristics are such that it has become a training ground for space agencies, which come here to simulate difficulties encountered during Martian missions, be they robotic or perhaps even human quite soon. Charles Frankel is a Franco-American geologist. As a specialist in the Red Planet, he has personally participated in several Martian simulation experiments.
This really resembles the planet Mars. The landscape is volcanic, like on Mars. There you even have an alignment along a fault, which is also to be found on the Red Planet. And then it's red because it's oxidized, like on the planet Mars. Mars was very similar to Earth at the outset. They're planets which had the same origin. During one glorious period, there were rivers and lakes which filled up, added to which there was a magnetic field, a shield which stops the atmosphere from being eroded by solar wind. 3.7 thousand million years ago came a turning point in the history of Mars. Things suddenly changed. The magnetic field coming from the Martian nucleus abruptly stopped. Mars was too small, its atmosphere ended up flying out into space. And consequently, Mars became a freezer. There was a sort of ice age, which suddenly took control of the Red Planet, and it never got over it. eventually becoming the dead planet it is today.
Has Mars retained the memory of its past? That's what scientists hope. The Perseverance mission began. Teams from the CNES and NASA's Jet Propulsion Laboratory get into the rhythm of Mars. Because on the red planet, days are longer than on Earth. Each Martian day, known as a sol, lasts 24 hours and 40 minutes, so clocks need to be synchronized.
So SuperCam is go for next cell planning. Over.
Great, thank you.
We begin the mission. We land. The reference mission is 3 years. If we break down before that, we will have failed.
On board, computer. Handing over the next bad, you got about 9.5 megabits.
The first objective for the scientists is to verify that Perseverance and all its instruments function.
Our rover has an auto-nav system, so it can self-drive on the surface of Mars. Driving on Mars isn't that easy, right? We don't have a map, we don't have a phone that we can just say, hey, send me in that direction. So what the rover does is it takes pictures in front of it. It actually looks 5 meters ahead. And so that way it can actually drive from 200 to 300 meters a day autonomously. So it will drive itself. We can say, hey, at the end of the day, just drive in that direction for an hour and a half and we'll see you tomorrow. And it will do that.
Communicating with Perseverance is not simple. Even though signals travel at the speed of light, a minimum of 30 to 40 minutes is needed to establish the slightest dialogue with the rover. For the first time, a displacement order is given, and 200 million kilometers from Earth, Perseverance begins to move. At night, the rover remains still. This is when it sends the information which it has gathered during the day to Earth, and it receives the very precise program of tasks to be executed the next day.
Each point of the image has coordinates relative to the rover. So when we tell the rover to home in on a particular place, it knows exactly how to turn its head to fix upon the point we want. After this, we tell it to take 5 aligned points in a particular direction with the laser, with infrared, with images.
It's a strange thing to say, but you really get attached to your rover on Mars. I mean, I spent 2.5 months living on what we call Mars time. You're essentially living on Mars with your rover. If you were to land me where Perseverance landed, I would know where to go because we spent so much time with the rover. And so it's strange to say, but it sort of becomes your baby.
We don't see it as a simple machine, in the sense that we follow its gestures, follow its steps. We tell it what to do on a daily basis. So with the slightest anomaly, the slightest difficulty encountered, it can also say, I have a problem, I'm held up, this is what is happening. It sends us elements. Then we use that to understand what's going on. We look at how we can help it to get going again.
We personify the object a bit. We say it's doing this when in fact it's us. But we render it virtually autonomous with all that we give it. There are some strange responses. From time to time we say, what did it say? We try to understand by looking at the log of what it said to us. It said something strange. We try to understand. It has its own life. Oh no, actually it was right. Sometimes its logic is stronger than ours.
She was very quick to get everything done, and I suggest we release her.
The first thing we did was the recipe. The recipe lasted 3 months, slightly more than 4 months. We calmly went about seeing if the arm was working well, if the wheels were good, if the head turned correctly. Then checked if the SuperCam could fire its laser. The laser twice, then the green laser, and then look towards the sun. Or don't look at the sun, but look at the sky. So we learnt about our instrument.
SuperCam even made it possible to immortalize, for the first time, an astonishing solar eclipse by the small Martian satellite, Phobos. The operational phase could at last begin. Perseverance's first objective: characterize the Martian ground. The rover landed in a crater called Jezero. This vast depression formed by the fall of a meteorite was carefully chosen by NASA over hundreds of other sites. It's one of the places on Mars where the chances of finding fossilized signs of former life are highest. Mandated by NASA, the geologists of the CNRS, Nicolas Mangold and Stéphane Lemoylic, often take over from their American counterparts in driving Perseverance towards the most interesting geological zones. Situated at 3,000 kilometers from where Curiosity operates, the site where the rover landed was totally modeled using images supplied by probes placed in Martian orbit.
Here we have a global view of Mars, allowing us to see the whole planet. You can see the different landing sites. This is the part where the rover, Curiosity, landed about a decade ago, the probe InSight in 2018, and Perseverance landed here. Here you can see the trajectory of the rover when it arrived. And what you see here is the Jezero Crater, which is the primary objective of this Perseverance mission.
The Jezero site, which is a very ancient impact crater, was chosen because it contains traces of a delta. We really have proof that a river formerly flowed into a lake, because to have a delta, you have to have a river and a lake.
It's a closed depression of about 45 kilometers, with a lake of a depth of about 100 meters, a little bit larger than Lake Geneva, and with sedimentary deposits, notably a delta which would have been 5 cubic kilometers, having sediment with a depth of about 70 meters.
The main idea was to have diversity. Having rocks which were at the bottom of the lake, rocks which were around the sides, and rocks which were on the delta. So a site was chosen where, in quite close proximity, this diversity could be found.
At present, the goal is for Perseverance to reach the delta. But the powerful cameras of the rover already display the geological layers that compose it.
In these strata, we see several layers, several different strata units, the lower ones of which were at the bottom of the lake, a calm bottom where clay was deposited. Above these, you have plunging strata which show that you're at the delta, where the water enters and goes down the slope. And above this, you have yet another different layer, full of large pebbles. Bang! Suddenly you're in a glacial period. You have lakes held behind ice dams, which break, and turbulent currents with rolling rocks arriving at high speed. So there is a really fascinating story to be read in the strata of the crater.
One day, the person on the camera said, "Look, there's a mound over there. Since it's a long way off, if we take a photo of the mound, it will serve as a reference point." When we saw the data arriving, we said, "That's marvelous. We're at the bottom of a closed lake." So we're getting results.
The photos were very revealing, but the virtual discovery of the crater was reaching its limits. It was now necessary to go directly to the study zone. For obvious security reasons, Perseverance advances slowly. By way of comparison, in a single day, the lunar astronauts covered by Jeep 3 times the distance that Perseverance does in a year.
In 200 days, we did about 2.5 kilometers. That's not a lot. It's about a dozen meters a day.
It's sufficient for working calmly, but too little to explore the immensity of the Jezero Crater, and each passing day reduces the chances of arriving at the much-prized delta. In an attempt to accompany the rover in its research, the decision was taken to release Ingenuity, the small onboard helicopter.
Ingenuity is a technology demonstrator. There's 3 challenges to proving that your helicopter can function on Mars, right? Atmosphere is one of them. The atmosphere of Mars is 1% the density of Earth's. So very, very thin atmosphere. The other 2 aspects, though, is the temperature. It gets very cold, negative 90 degrees Celsius overnight. The third aspect that's different from Earth is the gravity. It's about 1/3 the gravity of Earth. The way we test that here at JPL is we have a chamber about 5-6 stories tall. And in that chamber, we were able to balance the atmosphere, the environment, the temperature, and the gravity of Mars here on Earth.
Ingenuity weighs less than 2 kilos. It is equipped with 2 rotors turning in opposite directions, and it's 10 times faster than a helicopter on Earth.
For me, one of the most difficult moments on Mars is the day that we dropped the helicopter from the belly of the rover, where it was attached, down to the surface of Mars. I was in charge of those activities, and it was, I can tell you, incredibly stressful to make sure that our little friend was on Mars carefully.
Popped 3 meters off the surface of Mars, hovered for 39 seconds, and then came back down. We had that first flight. There were 4 remaining to round out our 5 total in our 30 days. And thankfully, at the end of those 30 days, Ingenuity was still healthy. The Perseverance team and NASA decided there's value here in continuing to fly on Mars. Ingenuity can act as a scout. We can fly to a cliff wall. We can dive down into a cave, right? We can go to very high altitude and loiter or do a lawnmower pattern over a region of interest, for example. Ingenuity today is already providing reconnaissance for the Perseverance rover.
Sent out as a scout, Ingenuity made more than 20 flights and sent back a harvest of high-resolution images to the rover. Perseverance could thereby choose its route towards the Delta.
We change history, and I think over the years we're going to see more and more flying vehicles on other planets because of the work that we did on Mars.
During its 26th successful flight, Ingenuity even made it possible to find the protection shield and parachute jettisoned during the rover landing. The route was mapped out. Perseverance could finally go back to its initial mission of looking for traces of life on Mars.
Because what we're once again looking for is not a macroscopic animal roaming around. If it was, we've slipped up, because that would be easy. It is very faint traces of what life probably was at some point on Earth, and perhaps also on Mars. Extremely simple bacteria.
Michel Vizeau is a trained veterinary surgeon and member of the European Astronaut Corps. His role today is as a world specialist in exobiology.
We talk about life, and when we talk about extraterrestrial life in general, we're focusing on the simplest element, which is the microbiological form, microbes. So if we find traces of a bacterial form of life on Mars, then we have found life, full stop. We found a new form of life. And if we find a solid trace of life, even fossilized, then that's it. There's a second form of life in the universe, and that's the answer we were looking for. But as for that developing into little people on Mars, that didn't happen.
The Viking missions, launched in 1975, showed that life, even in its simplest form, does not exist on the surface of Mars. If it is in the rocks, in the depths, or in the Martian atmosphere, doubt remains.
Let's say we found clues which could lead one to believe that a life form may exist today. There is talk of methane production. Methane could survive in the Martian atmosphere for a few tens or hundreds of years. If we find methane now, that means that it was produced recently. That means that in one way or another, at the heart of the planet, there's a methane-producing system. That could be a volcanic-type system, or it could be life.
Mars went through a period of 500 million, or perhaps even a billion years, when conditions were suitable for life. Was that sufficient for life to develop? I tend to think it was, because we've seen that on Earth, 3,700 million years ago, chemical traces prove that there was life in the Earth's oceans. Personally, I would like to believe that the same thing happened on Mars. And if this life took root on Mars, where is it today?
After a 5-kilometer journey, Perseverance finally arrives at the most awaited point of its mission, the delta at the mouth of the river.
If ever there was the beginning of a form of life, some prebiotic chemistry, it could easily be concentrated in carbonates, phyllosilicates, or clays. So these are the primary targets we're looking for.
On Earth, be it in the depths of the ocean or volcanic areas, there are zones which permit life to develop in very extreme conditions. And these extreme conditions probably exist on Mars, but we don't know which of them could favor life.
We think that certain organisms living in very particular places on Earth today could develop on Mars in certain microenvironments.
Purificación López Garcia is a specialist in microorganisms living in extreme environments. The Dalol hydrothermal site in northern Ethiopia is undoubtedly the most representative of these ecosystems in which all life seems impossible. Here, unicellular organisms live in extreme temperature and acidity conditions.
On the edges of Dalol, there are ecosystems where life can be found, particularly in the form of archaea. These are small microorganisms like bacteria, particularly well adapted to conditions of very high temperature, up to about 120 degrees, and very varied pH levels, sometimes very acidic. Study of these extremophile organisms makes it possible to better define conditions in which life could have appeared and lasted within other systems beyond the Earth. If life had emerged on Mars and could survive in such conditions, it could effectively exist in these systems, provided there was liquid water and the presence of energy sources. Also to be found in the Dalol thermal sources are places where there is liquid water, but no life. So great care is needed, because it's exactly at Dalol where small structures can be found which resemble microfossils, but aren't. They're mineral structures. So this adds to the confusion and clearly illustrates the difficulties, even on Earth, of finding the right signatures which genuinely indicate life. So a scientist going to Mars must be skeptical and obviously be adept at all types of techniques, which are more and more developed. They also need to be aware that they are tackling a problem which has no easy solution.
There is nonetheless a positive point which could help researchers. Unlike on Earth, the crust of Mars hasn't been renewed by plate tectonics. so Perseverance can carry out its research in very ancient clays. And if life has existed on Mars, the clays could perhaps still contain life constituents such as nitrogen or carbon.
To find intact organic molecules, it's best to dig down a bit to where they're protected, and the few centimeters which Perseverance's core drill is capable of are quite sufficient to arrive at the center of a rock, where they've been protected for millions or even billions of years. That should do it.
For the first time, the powerful core drill will attempt to gather organic elements which could be caught in the sediment. After examining the surface, the drill takes a first core sample. When completed, the robotic arm folds back towards the body of the rover in order to stock the most pertinent samples collected.
I would argue that that sample caching system is just as complex as the rest of the rover. It has to be able to take sample cores from the surface of Mars, process them, put them in the tube, and then pass that tube to another robotic arm inside the rover that then takes pictures, does some certain analyses of those samples, seals them because the samples are going to stay on Mars for a long time, and then it has the ability to deposit those sample caches on the surface of Mars.
We hope that these samples will one day be brought back for laboratory analysis, because for doing really detailed sediment analysis, there's nothing better than a laboratory with electron microscopes and high-resolution chemistry, which can't be done on a rover.
Perseverance will deposit a certain number of tubes, not all of them. So rather than make a final pile with all the tubes, with the risk of losing them all if the mission ends early, we make a chain of small piles, like Tom Thumb leaving a trail of tubes.
So to analyze them, the samples would need to be gathered and brought back to Earth. It's very exciting and very ambitious, particularly since for the moment, no one knows how to do it.
If you thought that collecting those samples and dropping them on the surface of Mars was already extraordinary and hard enough, eventually we're gonna wanna go bring those back. And so the teams here at the Jet Propulsion Lab and at NASA are already working on thinking as to how we might wanna do that.
That's the first time we're gonna launch something off of another planet. And then we have to bring it back home here to Earth and bring those samples back home safely and keep them contained. There are any number of challenges here that kind of dwarf anything we've done before.
The retrieval system won't be operational before 2028. But obviously, researchers on Earth are already working on this new challenge.
These tubes will be collected by a rover, a European vehicle, which will gather them with an arm, put them in a basket, like a grocery trolley, and deliver them to a place where there will be a rocket, which can put a container in orbit.
This rocket will probably need its own personal lander. It will need to land very precisely, not far from where the tubes are, because if it lands 100 kilometers away, that's no good.
The sample retrieval lander has a concept that we're working on right now, which allows the rocket that's going to take those samples from the surface of Mars to space to be thrown up in the air. We toss the rocket up in the air and then fire it. It's kind of like an air launch. And that's really the biggest advantage, is that we don't have to deal with any kind of erection system, right, to put the rocket in some kind of position that we want.
This vehicle, measuring 2 meters 80, almost 3 meters, will weigh 400 to 500 kilos. You throw it up in the air and bang, the rocket fires up. And before it falls back down, it has to leave.
Once the orbiting sample canister, that OS, is up in Mars orbit, we've got to find it with the Earth Return Orbiter. Remember, we're looking for something that's kind of basketball sized. That's pretty difficult, right? It's not a very bright thing. It's not very big. And we're going to have to find it from, tens to hundreds of kilometers away.
Putting a small white painted balloon passively into orbit around Mars and having a vehicle to catch it? That's not easy.
So we start by looking for the other parts of the rocket that have gone with it, that are bigger. The upper stage of the rocket has a radio on board with a beacon that will kind of scream at us every now and then, telling us where it is.
Next, the container is put inside in a capsule which will come back to Earth 6 months later.
6 mois plus tard.
The return of the capsule to our planet should take place in 2030. Perhaps in a few years' time, terrestrial laboratories will detect traces of extraterrestrial life in the samples collected.
Finding a form of life on Mars would be a revolution, because it would mean that terrestrial life isn't unique. If it isn't unique, you enter into mathematical induction, meaning 1, 2, and if you happen upon a third, then it's everywhere.
If all goes well, 500 grams of Martian rock and a few sample tubes will come back to the blue planet. It will be necessary to ensure that the tubes containing the samples have not been polluted by terrestrial organic molecules carried by Perseverance. Risk of contamination is weak, but could have terrible consequences if it distorts the results.
The first space explorers in the 1960s remembered one thing: the lack of precaution of their own predecessors. The spreading of illnesses at the moment of the discovery of the New World is an unhappy chapter in the history of humanity. Furthermore, the contagion took place in both directions. Terrestrial biological pollution in relation to a form of Martian life, once it happens, it can't be reversed. You could say the same thing about pollution of life on Earth by the Martian forms of life. An astronaut contaminated by an unknown Martian species, what would happen to them? Could they be brought back to Earth? Or on the contrary, never be brought back to Earth? Or would they be brought back to Earth but put in confinement for the rest of their lives? Sci-fi films have everything you can imagine for these sorts of things.
A lot of precautions need to be taken, but humans will go to the red planet. It's unavoidable. However, before even thinking of coming back, they first need to learn to survive on Mars.
So for Perseverance, in addition to establish whether there has been life on Mars in the past, one of the other goals is to prepare for the eventual coming of humans on Mars. And so we have a few instruments on board that allow us to prepare for that. There's the META instrument, which is a weather station. It allows us to understand weather patterns on Mars, not just wind, but also dust, pressure. There's a ground penetrating radar called RIMFAX that allows us to understand the structure of the ground below us. If we're ever going to build anything on Mars, understanding the Martian regolith is really important.
Jean-François Clairvoy is a French engineer and astronaut. He's already accomplished 3 NASA space missions. He knows that before you can send humans to Mars, robotic missions are absolutely necessary.
We need to demonstrate our capacity to go to Mars and come back in automatic mode before doing it with humans. So this sample return mission, to which Perseverance is contributing, is a key stage before deciding to engage in a human flight to Mars. But in order to send humans to Mars, you need to extract a maximum number of resources in situ for eating, drinking, breathing, and supplying the return vessel so as not to have to send everything from Earth.
Landing on Mars carrying 30 tons of consumables, including oxygen, to spend a few months there is impossible. But Perseverance can already help find solutions.
Perseverance is not just studying the geology of Mars. Perseverance is preparing the arrival of humans on Mars, because on its flank is a small box called MOXIE, which is the size of a car battery, weighing 17 kilos, and which converts the Martian atmosphere into breathable oxygen.
There is less than 1% as much air on the surface of Mars, but that air is 95% made up of carbon dioxide. So within each carbon dioxide molecule is an oxygen molecule combined with carbon. So the job of MOXIE is to take those apart.
So how does MOXIE function? It breathes in the carbon dioxide of the Martian atmosphere. It passes it through an electrolysis machine which separates out the oxygen and sends the unwanted carbon monoxide back into the atmosphere. Then it combines oxygen atoms to make breathable dioxygen molecules.
Now, you or I would take 20 to 30 grams an hour just to live and to go about our business. So far, MOXIE has run 8 times on Mars and it made a little more than 50 grams of oxygen, which means it would keep us alive for a couple of hours. We hope with a larger version of MOXIE to make all that oxygen in situ to support a human mission on Mars.
Humans will be much more efficient than robots once in place, because artificial intelligence only does what it's programmed to do. Even though it's quite sophisticated, you'll never hear a robot say, "Oh, look." I impatiently await the day when humans, accompanied by robots and cutting-edge scientific instruments, will be able to provide the beginning of an answer to the question, is there life elsewhere?
It's a fundamental question, and from a purely scientific point of view, it is even more crucial given the possibility that life on Earth itself comes from Martian life.
The panspermia hypothesis suggests that life can be transferred from one heavenly body to another by means of meteorites. We could be derived from Martians. It's not impossible, provided that Mars saw a life form develop before Earth did, and that afterwards, a sufficiently powerful impact happened while this life was flourishing on Mars, and that Martian meteorites arrived on Earth. The only way of furthering this idea would be to find a form of life on Mars which was intimately close to ours in terms of the 20 amino acids which constitute organic matter on Earth. If it were the same, we could say that the two form a community. If we ever find a Martian life which is different, that means we are really separated. We are two forms of life which developed independently of each other.
Mars bombarded Earth with meteorites. Perhaps the opposite is also true. The planetary snooker table and all the life distribution scenarios are possible. On Earth, in the solar system, or even all over the universe.
The question of the plurality of worlds and extraterrestrial life haunts the minds of philosophers, theologians, and more recently, scientists. Are we alone? That can provoke feelings. Either the fact of saying, "I'm afraid of being alone," could be terrifying in terms of responsibility. If tomorrow we disappeared from the planet, there would never be life in the universe again. Or it could also frighten us because we think, if tomorrow we discover our other life forms, then we're no longer alone. We're not the most beautiful. We're not the most intelligent. That would be a severe blow to our egos. And for certain philosophies and certain religions, it's difficult to accept.
It's the incarnation of our dreams to go to Mars one day, and I hope that it will happen. It's really the challenge of the 21st century. But I wouldn't like this dream to further the idea that it doesn't matter what we do on Earth, a second Earth awaits us. No, there's only one Earth and that's ours. This is our vessel. It needs taking care of. So that's it. It's the exploration of a planet, and that's already quite difficult enough.
I don't know who came up with the name Perseverance, but I find the idea quite extraordinary, because perseverance is one of the greatest qualities for a researcher. Perseverance is basically a name which you could give to all the scientific programs in the history of the whole world.
Perseverance will follow its quest for life on Mars for several more years. Whatever the results, the solitary robot will not just have provided a great project for humanity, but will also have supplied a good helping of dreams.
It's in the clouds. All I do is dream and facing the stars. All of them are blinking, and I feel small, and I love to know that there's no